Okay guys, so we're going to have a look at question 2, part B on 2019 Leaving Cert paper. Sorry about the lighting in here, but if I turn on the main light, then there's a big shine on this. So we're just going to have to go a little bit in the dark here. So this is a common enough question. It's come up a couple of times before in the past, particularly on mock papers, but a couple on some Leaving Cert papers. And it is incorporating a little bit of algebra into complex numbers. So it looks a lot more difficult than it is. So it says z squared minus 4z plus 5 is equal to 0. Show that 2 plus or minus I is a solution of this, or is a root of this, is another way of putting it. If this was x squared minus 4x plus 5, and I asked you to solve it, you would either say I'm going to factorize it, or I'm going to use the quadratic formula, which is the minus b formula. Because it's z squared minus 4z plus 5, it doesn't mean that we're going to do anything different, okay? So it doesn't matter that this letter is not an x squared, we can still use the quadratic formula. And if I use the quadratic formula on this, and I get an answer that turns out to be this here, then I know it's a solution of it, and I've proved it. So I'm going to use it's given to you in the table book for your Leaving Cert, minus b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to use that formula. Okay, anytime you need to solve anything that has a squared, single variable, and a number at the end, then you can use this. So a in this case is going to be 1, because 1 is in front of z squared. Okay, there's nothing in front there, so we assume it's 1. B is going to be minus 4, and C is going to be 5. Now make sure you get the signs right. That's a minus 4 for B. Okay, if you don't get the signs right, you won't get the right answer. And all I'm going to do is I'm going to sub these in here. So it says minus b, so I'm going to do minus 4 plus or minus the square root of b squared, which is minus 4 squared, minus 4 times a, which is 1, by c, which is 5, all over 2 times 1. Now, if you put that into your calculator, you will get an error. You won't be able to solve that. And the reason for that is because this is going to be a negative square root here. And remember, complex numbers are numbers that aren't real. Okay, so technically they don't exist, and we can't have a negative square root in real life. So you're going to have to do this out the long way, and that's something you're going to have to recognize. So if this comes up again, you're going to have to think to yourself, right, calculator's not going to help me here, let's just start multiplying out. Now you can use the calculator for individual bits here, but not for the overall thing. So minus 4, that's going to give me plus 4. Plus or minus the square root of minus 4 squared. Well, that's going to give me 16, minus 4 by minus 4 gives me 16, minus 4 by 1 by 5, 4 by 1 is 4, 4 by 5 is 20, so it's going to be minus 20, all over 2 times 1, which is 2. And I can tidy that up a little bit. I get 4 plus or minus the square root of 16 minus 20 is 4, or minus 4, sorry, all over 2. Now, this minus 4 is where the problem is. Right, I need to break that down. And I don't know if you remember this, but the very first thing you did in complex numbers was how to simplify down negative square roots. And have a little rule, which is given in the exam, and the rule is the square root of minus 1 is equal to I. So, square root of minus 1 is equal to I. So, if I have the square root of minus 4, the first thing I'm going to do is I'm going to look for a square number. So 4 is a square number, because square numbers are numbers that can be multiplied by itself. So 1 would be the first square number, 1 by 1. 4 would be the next one, 2 by 2. 9 would be the next one, 3 by 3, and so on. So I'm looking to factorize that, or to break it down into factors which have a square number. So I can rewrite this as the square root of 4 times by the square root of minus 1. 4 by minus 1 gives me minus 4. Square root of 4 is actually 2. Okay? So I can go 2 by minus 1, and I can replace minus 1, or square root of minus 1, with I, so that breaks down to 2i. So instead of writing the square root of minus 4, I can have 2i. So what I'm going to do here is I'm going to replace this. I'm going to do 4 plus or minus 2i all over 2. And then this one's a little bit hard to spot, but for the last few marks, I can simplify that down. Anything that goes into all three of these can be divided in, which in this case is 2. So I can divide 2 into 2, which gives me 1, which is effectively nothing on the bottom. 2 into 4, which is 2, and 2 into 2i, which is just I, or 1i. Okay, so what I have there is 2 plus or minus I, which is the solution here, which means that we've proven that this is a solution or a root.